G'day and welcome to the Seacreatures Podcast, a show all about the amazing animals that live beneath the waves. Each episode is about a specific sea creature with a guest who has spent time and interacted with this ocean animal. Our guests range from marine biologists to underwater photographers, citizen scientists, scuba divers, and anyone with an intense passion for marine life. My name's Matt Testoni, and I'm all of the above. And joining me for this episode of the Seacreatures Podcast is marine biologist, author, and octopus extraordinaire, David Scheel, and we're going to be talking all about the Giant Pacific Octopus. Welcome to the show.
Hi, Matt. Thanks for having me on.
So, before we jump into Giant Pacific Octopus, tell us how you became so interested in octopus in general and how you've come to work with the Giant Pacific Octopus.
Yeah, I got started up in Alaska working in the ocean after the Exxon Valdez oil spill, actually. And so my interest in octopuses came about in part because the shores here were coated with some of that oil, and some of the local communities were wondering how some of the shoreline creatures were doing, including in particular the octopus.
Yeah, and so that you get the Giant Pacific Octopus around that oil spill, or was it more octopus in general?
The most common octopus that we see up here, or what people thought was the most common octopus, is the Giant Pacific Octopus. And it's the largest octopus species in the world. And the Alaska natives here sometimes harvest it for subsistence food. And so they in particular were worried about whether it had been affected by the oil spill. In the end, we weren't able to say very much about that, the effect of the oil spill in particular, simply because no one had really collected any data on the octopuses along the shorelines prior to the oil spill. So there was no sort of basis for comparison.
So tell us what exactly a Giant Pacific Octopus is and how they're a bit different and where they're found.
The Giant Pacific Octopus is in a particular genus of the world's large octopus species. There's several species. The genus name is Enteroctopus, and the species name is Döflini, named after a German biologist, Döflein. So Enteroctopus döflini is the northern hemisphere species in this genus. There's another species or two at the tip of South America and at the tip of Africa, South Africa.
So we've mentioned, you mentioned two other kind of octopus in the north and in the south, and I just have to quickly touch on this because when I was looking up your details and your credentials, I saw that you discovered a species of octopus. Tell us a little bit about that.
Yeah, so it was in conjunction with some of my students, actually, but there's another large octopus up here that is possibly in the same genus of large octopuses, Enteroctopus döflini. It's genetically quite close to the Giant Pacific Octopus, but it looks different, and it's closely related, but it's in its own separate, clump. One of the distinguishing features that people have described from Africa, actually, in the genus Enteroctopus, is that it has these sort of wrinkles or folds in the skin of the mantle that run sort of the length of the mantle, longitudinally, rather than transversely. This other species that we found lacks those folds. And instead, the papillae, which are these sort of structures that come up out of the skin, they're actually erected by muscular action on the skin of the octopuses. These features of the skin, in the new species that we found, they make a frill all the way around sort of the equator of the mantle, so that they have kind of a flange or an edge around their mantle that's made up of these skin folds. And so we refer to this one as the frilled Giant Pacific Octopus. It hasn't been formally described yet, and so we're not entirely sure that in the end it will be assigned to the genus Enteroctopus because it lacks those folds, which previously to discovering this species had been a feature that was common to the genus, all the members of the genus, and we're not entirely sure whether that's true anymore or not.
Wow, yeah, because I've seen the little spikes that they put on when they're threatened or when they're communicating, but to have it as a frill would be pretty interesting. And to put it in perspective, how big, because I did a bit of research and there are so many different sizes that people are saying, but how big is a giant octopus of these species?
Well, they're well documented to reach sizes in excess of 100 pounds, 45 kilograms. So we know they get that big. And then, as you point out, there are these sort of claims that grow increasingly questionable, or at least less and less well documented as they get larger. And then that sort of merges into the sort of mythology of octopuses. You get questionable science, and then mistaken science, and then mythology, and it just sort of keeps going.
Yeah. What's your opinion on the biggest one? I've seen 70 kilos seems to be, the biggest reasonable estimate. Is that right?
Yeah, there's one that's been recorded at 156 pounds, which seems to me very believable, and that would be right about 70 kilos. And that record, I've spoken to the person who documented that octopus. It's documented in that, this is James Cosgrove. It's documented in his PhD thesis, and he recounts the tale of finding it and how he arrived at each of the estimates of its weight and its arm span. So that one seems to me fairly well documented. And then there are larger ones yet that are less well documented, but are commonly cited.
And what about how big is their arm span? So I presume from the end of each arm to the other end of each arm, given that octopus don't have tentacles, is that correct?
Right. Octopuses have 8 arms and no tentacles. Squid have 8 arms and 2 tentacles. The arms have suckers from the mouth out to the tip, generally. Tentacles of squid don't have suckers along their length, but they have suckers at the very end, and they often end in a specialized structure called a club that is really just a widening of the arm that's designed to help grab a hold of things that are very fleet and fleeing, like a fish, because the squid are more often fish specialists, and the octopuses are more often crab and clam specialists. The arm span is such a difficult way to measure the size of an octopus, particularly after death. The arms are quite elastic, and as they relax after death, you can get very long arm measurements out of these guys. Sometimes you don't see that even reported in the records of these animals and their size, and sometimes you see it estimated. I know that James Cosgrove saw his animal in captivity, this very large one. The actual size in feet is given in the book, Many Things Under a Rock, The Mysteries of Octopuses, when I recount that. But he was able to get that estimate by looking at the animal in captivity as it reached from one side of the enclosure to the other and simultaneously touched, sort of the viewing wall and the opposite corner. And then James was able to go in later and measure that dimension. And that's how he got the arm span of that animal.
Now, you mentioned your book. Is that arm span in the book? And then tell us a little bit more about your book before we continue with some more octopus facts.
Yeah, the sizes of various records are discussed in my book, Many Things Under a Rock, The Mysteries of Octopuses. It's out by Norton in the United States right now, and it comes out from Hachette Australia Publishers on the 11th of July in Australia and New Zealand. And the size records I actually discuss, I think, in Chapter 2, when I'm trying to figure out whether it's safe to take a team of divers into the water to try and capture giant Pacific octopuses. And as we've discussed, the size records are so unclear how big this animal gets. That became kind of a burning question as I was trying to figure out how do you capture these animals safely for scientific investigation. And so they're in the book, Chapter 2, and the related footnotes often have the details.
All right, I have to ask, tell us how you go about diving down and capturing or interacting with one of these octopus. Like, talk us through. Are they dangerous? Are they not?
Well, it turned out that nearly all of the ones that we worked with here in Alaska were juvenile octopuses. It's just kind of axiomatic, I guess, that you more often encounter the juveniles than you do the very, very rare and largest adults. And so generally they're quite manageable, and we've found them at every size from sort of thumb size of, I think, just a couple of grams, maybe 4 grams. I forget if we had any smaller than that. I think the smallest one was just under 2 grams that we recorded on the bottom. Now, we're not talking about in the plankton because they do have an even smaller planktonic stage. but on the bottom, all the way up to, 65, 70 pounds, I think was the largest one I ever handled. Generally speaking, all you want to do in capturing them is get them into a scuba diving goodie bag. It's a mesh bag that the water flows through that once they're in the bag, they're very manageable. And so, it's just this question of keeping them off of the bottom, because if they can reach the bottom, they've got 8 arms, you've got 2, and, their suckers will adhere. And at that stage of trying to handle an octopus, if you're not careful, you're quite likely to injure the octopus. The larger ones here in Alaska can be dangerous because they can hold on to a person. And if it's a large octopus holding on to you and holding on to the bottom simultaneously, that restricts your freedom to get back to the surface. And so there are some accounts of divers or swimmers being held onto by octopuses that can be threatening. But as far as I've heard, there haven't been any deaths.
So when you're not capturing, though, I presume you've had a lot of encounters as well when you've swum down and you've found them and you've investigated them. Tell us what it's like to encounter one when it's not a science and capture kind of experience, but just a wow, look at this amazing animal experience.
Yeah. They're brilliant to see underwater. There's 2 things that are really striking. First of all, how they move is very fluid. We're used to seeing maybe a fish dart through the water, but they're a little more like, if you will, like a sea snake, in the sense that they have that sinuous movement to them. But they're very different from a sea snake as well. A sea snake is operating against an internal skeleton, and it allows it a great deal of sort of S-shaped movement through the water. An octopus is not, and they sort of cast their arms forward if their arms move ahead of them, very much like the crack of a whip, but in slow motion. And then when they're fleeing or pouncing on something, they're jet propelled, and the arms are sort of trailing behind them. So it's a bit like trying to sort of throw a scarf through the water, if you will. And as it trails out behind, the water pushes against it. It's very graceful and beautiful. And then the second thing about their movements is they're very well camouflaged. And so they very quickly take on the appearance of the environment. It's actually quite a trick to keep your eyes on them as they move about, because they're very, very good at blending in with whatever's around them.
Yeah, I've had one before that I've come across on the Barrier Reef, and it's been blended in perfectly with the coral. And then you watch it for about 30 seconds, and then it kind of gives up on its camouflage. It goes, I've been seen, and then it kind of jets off and does a whole bunch of different colourful displays. Do Giant Pacific Octopus change colour as well? Is that all octopus or just some?
Yeah, I don't know if it's all octopuses. Maybe some of the mid-water ones are not so good at that, although they have their own tricks. There are sort of transparent mid-water octopuses, and they've got their own ways of staying invisible. But the Giant Pacific Octopus here is color changeable, very much like the ones you have down there. But it doesn't live on the coral reef; it lives in kelp beds, and so it has a completely different appearance. And its color change is oriented towards blending in with kelps rather than with corals. And so, I've seen them here dive into the kelp, and then they erect these projections of their skin, the papillae, and they take on the same color as the kelp, and then these papillae make them look like the sort of rippled edges of kelp blades. These are not green kelps. These are brownish-red kelps, the laminariales kelps. You have similar things down there, but you also have a lot of green kelp down there. And when they do that, they sway. They have enough skin that's very loose that they sway in the water, just like the kelps do. And they watch your eyes, and they wait, as you mentioned, right? But I've had them wait until I glance away, some distraction or whatever, and you glance away for just a fraction of a second, and that's when they make their break for it and change appearances and jet off and ink in the water and dart in a different direction. They've got a whole sequence of moves to make sure that whatever you're looking at, it's not them anymore.
Yeah. They're just such cool animals. Tell us a little bit about the ink. And Because is it like, I suspect, a magic trick where you throw out a bit of powder and you disappear? Is that what they're doing, or is there something else about ink?
It's a bit like a magic trick because, the point of the powder in a magician's show is to draw your attention over there while the magician does something else. And that's kind of one of the ways in which octopuses use their ink. The octopus ink is secreted by an ink gland, and it's mostly melanin. As it's ejected, it's mixed with mucus from a separate gland. You get the octopus choosing at the moment it's inking how much of the ink to secrete and how much of the melanin, or how much of the mucus, to mix with it. And so you can get ink clouds that are more heavily mucus and they hang together in a blob in the water, or more heavily the ink alone with less mucus that tends to diffuse more quickly. When they make that blob that hangs together, they'll secrete an amount that will leave a shape hanging in the water of about the same size as the octopus. And the ink and the octopus can be very similar in color. So they squirt out the ink blob, creating a shape that is being visually tracked by you or whatever else is pursuing them. And then they will immediately change direction and go to the bottom and adopt the camouflage of the bottom. So that thing that you were visually following, in the moment that you're trying to tell ink blob or octopus, the ink blob stays right there, and the thing you were tracking, the octopus, changes appearance entirely and stops moving. And so that's when you lose it.
Wow. And is that a pretty good strategy, or are there predators of the octopus that know what's happening?
I found it to be an excellent strategy, and I have lost octopuses, in that moment. When you know what you're doing, you can say, ink, look past it immediately. Don't look at the ink. You can tell yourself attentionally, don't look at the ink. Look past the ink, because that's where the octopus is. If you look at the ink at all, that's when the octopus loses you. I don't know if there's predators. I imagine there are predators who can learn that trick, right? Don't look at the ink. But they'd have to have some experience with octopuses, I would imagine. And then there are predators that follow octopuses in the dark. They follow octopuses by scent or other means. And so if you're not tracking visually, then you probably wouldn't be fooled at all by the ink blob itself. Some moray eels forage at night, and those are probably tracking by scent.
Yeah. And so speaking of predators and prey, I have to ask, I know there's a few stories of giant Pacific octopus capturing small sharks. How does that work, and is that true?
Giant Pacific octopus capture all kinds of interesting things. And, there's a couple of great accounts of octopuses. One, a giant Pacific octopus that captured a bird and dragged it down underwater. The shark instances that I'm aware of they were filmed by a photographer here. I wasn't there when those images were filmed, but I understood that it was a large octopus and a small shark in a tank together. And the shark is at a disadvantage there. Eventually, the octopus is just going to catch it, and the shark doesn't have much chance to escape at that point.
So I know they have a beak, but in terms of capturing a shark or a large fish, how does the octopus deal with its prey?
Yeah, generally speaking, the octopus engulfs the prey in the web, and so it's holding on to it with suckers and arms, and it engulfs the prey in the web, at which point the prey is sort of covered. It can't see out. But also, the prey is somewhat restricted in what it can do. But octopuses have a lot of tricks for this. So, it sort of depends on how much fight the fish has in it. If it's a small fish, it may not have very much fight in it. I have watched a video of an octopus that had been attacked by a much larger moray eel. The moray eel had gotten a hold of the octopus by one arm. I'm sure the octopus didn't want to fight. This was not a fight the octopus had chosen. But he couldn't get away because the moray eel had one arm in his mouth. But the octopus had then wrapped another arm around the moray eel's jaw, so that the moray eel could not open its mouth to take another bite. And in addition, the octopus was running other arms into the gill slits of the moray eel, which was probably restricting the moray eel's ability to get new oxygen. It was suffocating the moray eel. And then in at least part of the fight, the octopus, yet another arm, had grabbed the tail of the moray eel and pinned the tail of the moray eel up against the moray eel's head. So the moray eel couldn't breathe, couldn't bite, and couldn't swim. And the octopus definitely had the better of the situation for a few moments. But the moray eel is very flexible as well, and it got its tail free by thrashing. And then it tied itself in a knot, the moray eel did, and slipped the knot from its tail up along the length of its body until it was able to shove the octopus off of its head and out of its gill slits by sliding this knot up of its own body length up along the length of its body and over its own head. And so that ripped off the octopus's arm, but also shoved the octopus off of the moray eel so that the moray eel could move again. And once it got free, the moray eel took a moment to orient itself. And in that moment, the octopus used all its escape tricks. It inked, fled, changed direction, changed color, and the moray eel, by the time it got its wits about it, just bit at one of its ink clouds, and that's all it got. That and the arm that was stuck to its head.
Wow, that's amazing.
Yeah, it was a pretty impressive bunch of tricks in just a few seconds.
Yeah. So putting the arms inside the gill slits and kind of pinning the tail, it sounds like pretty intelligent behavior. Is that something learned, or because I know octopus are pretty smart, but how do you think it came to know to do that?
You know, they have a pretty good toolkit of techniques, and the techniques get used all kinds of ways, right? So when an octopus wants to subdue its prey, it pounces on things, it tries to get it under the web, but in order to find its prey, it's got to investigate crevices. And so investigating crevices and holding on to things are pretty much the way an octopus works. And so, you know, there's a sort of a deflationary account of this incident with the moray eel, in which the octopus is holding on and fighting for its life. And so, you know, clinging to things comes naturally, and trying to hide in crevices comes naturally. And so there's a level of understanding of this incident in which that's what the octopus is doing. It's got a big toolkit of tricks, and it's trying all of them. But some of the most basic tricks are hiding and crawling into tiny spaces. And so it's exploring whether it can do any of those tricks at those moments with the moray eel. And eventually, when it gets free, it tries a different portion of its toolkit. The portion that has to do with changing its appearance, using its ink, fleeing and changing direction. So they practice them, yes, but probably not all at once against moray eels.
Yeah, okay, so it's more just trying anything it can to escape rather than being like, I'm going to put an arm into that gill slit.
You can imagine it's using all its tricks that it knows to prevent the moray eel from taking pieces of it, which it fails at that ultimately, but from taking it as a whole, and it wins at that ultimately. It's probably not necessary to imagine that the octopus thinks, I'm going to hold this guy's mouth closed and suffocate it and prevent it from swimming until I can figure out what to do next. The octopus doesn't necessarily need a strategy so much as it needs great reflexes and opportunity.
Yeah. And so talking about the octopus's toolkit, I just have to ask as well, because they don't just eat fish and different things, they also eat different shellfish. And they have a different technique for consuming that, don't they?
Yeah. Octopuses eat some of the best armored animals in the sea. I mean, they open clams, they subdue crabs, and these animals have these hard shells that cover them and protect them from exactly this kind of predation, one would think. But the octopus has its own toolkit for opening its prey. And the three main tools in that toolkit are suckers and strong arms, as suckers can adhere to the surfaces of these armored prey, and then the strength of the arms can potentially just pull them open. When a crab or a clam is small enough, a large octopus can just pull it open and get at the insides that way. Octopuses also have an organ inside that's a bit ribbon-like or tongue-like called the radula, and it's coated with very hard scales, so it's a little bit like a file. And the radula can be pulled back and forth across a surface to sort of scrape away at the surface, and we speak of this as drilling because in the end the octopus can make a hole in the shell that's quite tiny, but it's not spun like a drill, it's rasped. And then in addition to that, they have a salivary gland that secretes saliva that contains enzymes or toxins, and the enzymes in particular will break down the armor. And the salivary gland administers this mix of chemicals to the shell through an organ called the salivary papillae, which is a little thin, tube that is modified at the end to allow the secretions to be delivered to a very pinpoint spot, and that softens the shell. So the salivary papillae administers this mix of enzymes in the saliva that soften the shell, and then the radula, or in some cases the organs at the end of the papillae, scrape that softened material away, and the octopus can drill a hole directly into the soft tissue through the carapace of a crab or the shell of a clam. Once they can secrete the saliva through that hole, the enzymes will continue to dissolve the attachment of the muscles to the shell of the prey. That ruins the ability of the prey to hold itself closed, and the octopus can then open it even if it wasn't strong enough to do that against the strength of the prey. And then if none of those work, there's also a beak, and the beak is much like a parrot's beak, but it's more fully embedded in the musculature of the mouth. And the beak is very blunt in the octopus, and it can be used to crack or chip away at the edge of a shell. So the octopuses will use any or all of those three techniques to get into really heavily armored prey.
Yeah, I mean, they're just so amazing how many different strategies and abilities and functions they have. It's incredible.
Yeah, they have an immense diversity of adaptations to do things that, in some ways we often think, we're very manipulative. We humans are very manipulative, but we use our hands. And we don't often think about the fact that sometimes we manipulate things by biting them or using our lips or our fingers, or occasionally you'll try and crack something with your elbow, or sometimes your forehead. And so the octopus has these toolkits and a very diverse set of ways of approaching the world, because it's got arms, it's got suckers, it's got a beak, it's got a radula, and so on.
So we've spoken about quite a few different things and quite a few different facts about the octopus, but are there any other specific cool facts about the giant Pacific octopus that you think really stand out?
Well, I mean, the most notable thing about the giant Pacific octopus, of course, is that it is so large. And then it has a unique adaptation to the environment that it lives in up here in Alaska. It matches the kelps that we have here. And because it grows so large in cold water, its way of movement is affected by the temperature. Things happen faster in warm temperatures and they happen more slowly in cold temperatures. And octopuses have this incredible ability to manipulate the way their genes are transcribed into RNA. I'm not a geneticist, so I hope I have the details of this right. But that ability to revise and edit their own RNA is one of the tricks they use to adjust to the temperatures and for the different species to adapt to the different temperatures, particularly the cold water species. And so this allows the cold water species to grow large, but also they tend to be a little bit slower. They've had to do a lot of modification to adapt to the cold water and allow their nervous signals to be quick enough. And so they're very fast for a mollusk. But I was kind of astounded the first time I encountered tropical octopuses that they are faster than these big guys that we have up here. And so we kind of think of these big guys up here as sort of gentle giants because in some ways they're a little slower, partially because they're larger, but also partially because the water's colder up here. And the tropical ones seem to be a little bit quicker in their movements, and so they come across as a little more aggressive.
Wow. That's one cool fact, genetic editing. Wow. Well, just before we wrap up, if anyone does want to see Giant Pacific Octopus, can they see them in the wild, or is it best to go to an aquarium, or what would your advice be?
In North America, in the U.S. and Canada, I think the Giant Pacific Octopus is the most commonly displayed octopus in captivity and at the public aquariums and things. And I think that the aquariums in particular like to hold the octopuses, and get them as big as they can because it's a very impressive animal. But scuba divers can see the Giant Pacific Octopuses in a lot of different dives in Puget Sound area around Seattle and Vancouver, and the local dive communities there are absolutely wonderful at knowing the places where people can see these. If you're fortunate, even walking along the intertidal, along the shorelines at low tide, these animals can be seen even that way. There was a Giant Pacific Octopus filmed just recently at Haystack Rock in Oregon, right up on the tide lines. Makes a wonderful little video clip as these guys try and encourage this animal to head in the right direction, back into the water and back out to sea. And up here in Alaska, that's how I usually find them, is walking along the shorelines.
Wow, just taking a stroll on the beach, I guess.
At the very low tides, yeah.
Yeah, wow.
Of course, they're usually hiding out in their dens, and you end up seeing a den rather than an octopus. But sometimes they're out, even at low water.
Yeah. Well, that kind of brings us to the end. But before we finish, tell us a little bit about how you can find out more about octopus, specifically with your book.
Yeah, so the book is Many Things Under a Rock, The Mysteries of Octopuses by David Scheel. That's me. And I tried in this book to relate everything new and exciting about octopus and octopus science. There's lots more in there. It's full of great salty stories and sea yarns of all kinds. This is the author speaking, but it's a great read. So take that with whatever grain of salt you like. It's a very informative book that covers sort of this new understanding that we're coming to about octopuses as these animals that are doing very unexpected things in very unexpected ways, but ways that make a lot more sense when you understand a little bit more about the animal. And so that's what I've tried to convey in Many Things Under a Rock. It's out in the U.S. right now from Norton Publishers, and it's out in Australia and New Zealand on the 11th of July.
Awesome. Well, it's definitely on my reading list for the next book, that's for sure. That brings us to the end. Thank you very much for being on the show.
It's been my pleasure. Thanks for taking the time to speak with me.
Seacreatures Podcast is hosted, edited, and produced by myself, Matt Testoni. You can see my photography on Instagram at Matt_Testoni_photography. Check out our guest David Scheel's webpage, which is alaskaoctopus.com, and his new book, which I can tell you is definitely awesome. If you've liked the show, jump onto our Patreon account, which is patreon.com/Seacreatures-podcast, where you can help with a little monthly donation to help with the running costs of the show. Production assistance by George McGrath, and music by the talented and amazing Dan Musil. Coming up next time on the Seacreatures Podcast, we're going to be talking to Ollie Dove, all about her work with the amazing seabird, the shearwater. This has been the Seacreatures Podcast. Over and out.